Well, good morning, everyone. My name is Christine Frank, and I'm really glad that you're here today. Welcome to our session on industrial IoT architecture. Before I introduce our special panelists, I just want to introduce myself real quickly. So I live in Minneapolis, and this morning we're getting a snowstorm. So hopefully after this, I can still drive away and I won't be living in my office. So for today, I'm just going to ask some really good questions around the architecture and make sure everybody understands it. But this isn't about me. This is about our distinguished guests. So let's start with Richard. Richard, why don't you introduce yourself today?
Good morning. Thanks, Christine. Richard Turon. I'm the product manager for Field Server, which is part of the MSA safety. And we've been in the protocol business for over 20 years. And in the last 10 years, we have an IoT solution connecting devices to the cloud.
Excellent. Don, would you like to introduce yourself?
Sure. Hi, I'm Don Steed. I'm the Director of Software Product Management at Eurotech. Eurotech just had its 30th year anniversary. Its legacy has been in the embedded compute space, but similar to Richard, about 10 years ago, Eurotech introduced an IoT platform through the Eclipse Foundation, and now it's become an integrated hardware and software platform with our embedded compute, and then now with our IoT platform, so having a complete solution.
Fantastic. That's great, Don. Paul?
Good morning, everyone. My name is Paul Hepperla. I'm the Vice President in Eaton's digital office, and we are working on digital transformation of Eaton internally, as well as our customers, and industrial is one of the large customer segments we serve. So happy to be here. I'm happy to talk about what our journey is and to have a good, honest discussion.
That's fantastic. I hope you guys aren't freezing like I am here.
No.
So anyways, well, before we get started, I'd like to just show a quick little view of an architecture. And it's not specifically to everyone here, but it's a really good overview of how we look at IoT, Industry 4.0, and industrial IoT. So I'm just going to share this real quick. If I can get it to go. Well, it doesn't like me. Let's see. Sorry, guys. Not trying to. I don't think anyone can see it.
Yeah, we're seeing your screen, Christine. We're seeing it in the slide viewer mode.
Oh, you are? Okay. So this is a really good diagram as we've progressed over the last 10 years from machine to IoT and industry of things and industrial 4.0. This just really shows you from left to right how the three areas actually come together. And as we talk about the architecture, I think it's a really good visual as we go through some of the questions. And now I have to turn it off. So just a second here. All right. So that was just kind of a brief little picture of the architecture and where we really want to start today. And I'm going to start off first by saying, what is it that you guys feel is, what does edge mean to each one of you? Let's start with you, Paul.
Yeah, so edge for me is anything related to the asset. So it could be a sensor or it could be a control point within the asset. That's how I would view edge. And I know that we've probably got some different variances of that, but that's how I would view edge. Is that the asset or the device or the sensor?
Okay, perfect. And what would you say it is, Don, in your viewpoint?
Yeah, for me, I consider everything the edge that is not cloud related. So it could be anywhere, as Paul mentioned, coming from the sensor, could be gateways, edge compute, could be a server even that is being used at the close to the instrument or to the sensors. So really, to me, it's just about everything that's not cloud related.
Perfect. And Richard, what is your viewpoint on that?
I think my viewpoint is edge device is very close to the source, and it has a certain amount of intelligence built into it and connectivity.
Fantastic. The reason why I always ask that question is because we all come from different worlds, whether we're from the IT side or the industrial OT side. Sometimes we don't always know what edge means to each other. So it's always really good to kind of get a basis of that and where it starts. So bringing that up, before we get into any more questions, I'd actually would like to ask a polling question. And I believe you guys have that polling question. Maybe they don't. Sorry, I thought we had a polling question. Basically, what I wanted to ask is, from the audience that's out there today, how many of you consider yourself IT people? I guess we'd have to put it in the chat. That would be the only way, or raise your hand. Well, okay, we've got Connor who says me. So, oh, perfect. Here we go. So basically what I want to do is just make sure I understand your background, and maybe you're both. So if you could, I'll take a little bit of time here to answer the polling question. That would be fantastic.
All right, 5 more seconds and we'll stop the poll.
Oh, perfect.
All right.
All right, let's look at the results here. Oh, that's really good. We've got quite a spread here. And I'm really excited to see that we've got a lot of people that are working on both sides of the house, as I call them, carpet and cement. The IT side is the carpet and the OT is the cement. That's fantastic. That really helps now that we can talk about more than just the IT side or the OT side. So thank you very much for that. So let's kick it off with this question. When starting a project around IoT Industry 4.0, where is it that you believe that we should start? And I'll start with you, Richard.
Thanks, Christine. I firmly believe one needs to understand what is the objective. What am I trying to achieve? And then have a look at the pieces that are needed to achieve it. It could be as simple as, I want to get email notification. I want to get remote connectivity. I want to put intelligence, additional intelligence next to my device. As soon as you understand your requirement, and then you can look to, okay, what do I need from there? And then start to build a solution from your objectives.
Perfect. What do you think about that, Paul?
Yeah, I really think you have to start at expected outcomes. What do you expect to achieve? And if you look at the history of IoT projects, many of them fail because I think there's less than a solid business case, and it's more focused on tech and technology and the coolness factor. So I think as we move forward, you have to start with expected outcomes because that will lead to the architecture. And part of that's about what do you need, when, and where from a speed perspective, and from a latency perspective, and from a cyber security perspective.
Absolutely. And you don't want to swallow the whole elephant, right?
Yep.
What do you think? Do you think that you need to really decide with a team or that group on really what the biggest problem is or the easiest thing to fix? How do you think that actually comes out?
I think you have to find the mix of that. If you have a very big, hairy problem to solve, but it's going to take you 6 years to implement and get it solved, then you have to go question the premise, take it a bite at a time, a phase at a time, and show success as you move along. So I think if you have, starting off with that expected outcome, if you're moving towards that, You should have the granularity to understand at what point does it start to be measurable and make a difference. And part of this is also capturing the human side of it. So you can employ all the best technology, but if you are not capturing the human context of it, it will become problematic over time.
Richard, how do you feel about that?
Yeah, very much so. As Paul indicated, to understand the technologies that are available, and also the suppliers as well, because so often it's been my experience that people are trying to generate everything themselves. And if you look at the AWS is today, and Azure, and a host of other platforms that are out there, and the features that they can offer to the solution provider to get a product together. And I've just been noticing some of the questions come in. Security is a big one, and it's one of the first things that one will consider when going down this path. And there's a lot of security features that a lot of these big platform suppliers offer. And the thing is to understand what you're after, and then to see what is available from different suppliers, so you can put your solution together and get it to market. Because as I said a little bit earlier, you want to get something out there. It's happening today. It's not something 6 years down the line. I believe most that window of opportunity if you wait too long.
Well, that's absolutely right. And trying to understand what you want to do with the data and the teams is really, really important. So here's a really good question about it's from an anonymous caller. I'm not sure who he is, or she. One of the questions that they asked was, what do we mean by IT teams in manufacturing? And do they prefer PAM solutions over edge devices in the OT network? So it's kind of talked about the architecture. Really, that question is, what do you think is needed out on the manufacturing floor versus the IT side to really come together with an IoT solution? Anybody want to answer that one?
I can take a start at it. I think it really depends upon, looking at what you're trying to achieve. There's 3 levels of it. One is on the HMI and on the human machine interface on the machine. And that's going to be for real-time interaction with somebody or something that's managing it. When you think about that next level, it's around speed and latency. And so if you need to be making microsecond decisions, that's not something you build into the cloud. It's something you build into the machinery. If you're looking at a 5-minute window, you get some variability in where that is. You're looking at a 15-minute window, and you continue to move out the more and more you move towards the cloud. So when you think about trend analytics that might be providing a day+1 view around how well did it perform, or what was the efficiency, or where are the potential problems in some of the predictive nature of that. I know that as we think about analytics, our view is that some of it will be applied in the machine, some of it will be potentially applied at a gateway, and some of it will be applied in the cloud. So it really depends upon when do you need the information and what do you plan to do with it, because that speed of information is going to really factor into what becomes an edge device and where you're doing the compute.
Yeah, absolutely. Edge devices is another interesting thing, because there's so many different ones out there on the market, and so many different ones that use different software. How do you guys feel about edge devices, and how do you select one, and how do you look at it from the standpoint of the engineering application that you might be working in?
Sure, I guess I'll take this one. So, it really comes down to back to the initial question: what is your objective, right? And then it starts to dictate kind of the workloads. So if your workload is really just to get sensor data, maybe a handful of sensors, and you want to get that to the cloud and visualize it, That's got to be a simple workload. So you don't need, a very complex edge device. But then as you start to do, things like putting a software stack, maybe you're trying to do some filtering of your data, or you need to do some, even more sophisticated things like, threshold detection, those types of things. Well, you're going to need to have a device that can run those workloads, right? So you're really looking at kind of like, what am I trying to do at the edge? And this gets into, back to that architecture conversation where, what types of intelligence do I want to apply at the edge versus maybe in the cloud? Things that need to be more real time, more complex workloads, things like predictive maintenance, AI, those obviously have to have a fair amount of horsepower to run. And so that's really going to dictate, what devices and where you want to use those software stacks.
Well, and also the environments are different, right?
Yeah.
So selecting the right gateways for the actual environment is really important. So what do you guys think is one of the biggest problems in IoT that we can solve?
I mean, I'll put
That's
it
a
as
loaded
this.
question, but it's
I'll put it as this. I would call it applied observability, which is basically saying, how do we take machine information and tie to that context around operational aspects? So are we looking at a line where we've got 17 different pieces of equipment and we've got human interaction with that? Is it fully autonomous? So that applied observability, that word is tough to say, I think is one of those big things, which is it's really a marriage of technology and human interaction to look at how well are we performing, what are the potential points of failure, where do we have single point of redundancy, where a single failure might mean the shutdown of a line. Those aspects, I think, are purpose built for solving with IoT. I think just to the point of around the discussion around architecture, many of prolific amount of IoT devices, but the interaction between those devices is what I think is the bread and butter of what we should be focused on, rather than simply the edge point solution, because now you're going to have 35 different providers with 35 different ways of viewing it and approaching it. And unless you find a way to marry that together to make sense of your business, then we're not solving anything.
So that's a great question then that comes up is standardization. And do you make something on your own and bake it, or do you buy? How do you feel about that, Richard, when you think about solutions?
Yeah, very good question. The one that comes to mind straight away is that my connection to the cloud. Do I create something? Do I utilize what's available from the AWS or Azure, or do I follow some industry standards like MQ, TC Sparkplug? So it's why generate something yourself when there are these features available from the different providers that can assist? Because if I do something myself, then tomorrow I need to change the environment, and that connector might not work with a different provider. So I firmly believe to follow industry standards out there. And it's not just features of product, it's security is actually a feature of product. Even with regard to security, which is another interesting topic. What do we need to do to mitigate security risk or cyber attacks? And obviously you need to present that to customers. And if you then can present, yes, we do meet the following, I think it's a step in the right direction straight away.
So you brought up an interesting point, and I'd love to hear Don's perspective on this, but you brought up a really interesting point about vulnerability and security. Don, how do you feel that security should be managed? Should it be done with the OT folks, with the IT folks, or both of them coming together? And should they be using standardized types of software for security?
Yeah, I would say, from the perspective, traditionally, some of the OT systems had been kind of firewalled, they're blocked off. And now as you're starting to see this IT, OT transformation, the IT folks have been dealing with security and definitely open communications and securing those for quite some time. So from my perspective, the IT people generally are the ones who have been working in security and in flexible environments, and those are where the velocity of security, as a lot of the approaches have been facilitated and generated. So I think it is a combination. You can't do it in a vacuum, right? So you're going to probably lead with your IT folks when it comes to come with some of the security architectures and approaches. But obviously that integration with the OT team, that's your IT, OT, transformation. If the two don't come together, you're not really doing IoT.
So that's another really great point. How do we bridge the gap between the IT folks and the OT folks to really sit down and come together as a team? And who takes responsibility on which side?
I mean,
I see Paul really wants
Yeah.
to jump on this.
no, I would just say this is that what I see, where I see mistakes happening is people jump to the technology. And if you jump to technology, you're talking two different languages. And it's going to result in a lot of stalled processes and stalled projects. If there's an expected outcome, which then leads to the discussion around architecture, then I think you have a pretty clear line of delineation between who's responsible for what and how does it move forward. And so if you want to figure out how to get IT and OT talking to each other, start with the business aspect and then move into the technology aspect. If you start talking immediately about, hey, we need Modbus or OPC UA here, and the other one's saying, no, we want to use MQTT and we need to have a push environment only, I have a hard time understanding how you're going to actually get to the outcome in a very fast, efficient way. If you start talking about, this is what we expect to get information. Some of this will have to be, near real time. Great, where should that sit? And then the whole idea of cybersecurity is IT as the governance aspect and OT looking at what's the business impact. And so there's vulnerability in old devices. If it's got a microprocessor, there's a potential for vulnerability and there's a potential for a problem. So who manages that? Well, one is governance around vulnerability assessment, but then who actually manages and executes on that? That's going to be a combination of IT and OT. And does IT know every single piece of equipment on the plant floor, its importance, and when it's scheduled for replacement? Probably not. But from a cyber perspective, that we've created our own issues with cyber because we're adding more and more connected devices. So managing that takes both sides of the aisle, like Don said, but IT from a governance standpoint, most likely OT from an execution standpoint.
So that brings up another really good point. And this is something that a lot of people struggle with is if I'm working out in a manufacturing plant or site or facility, when is the best time to even use IoT? What if my process is manual versus automated? Does it make sense? Anybody want to? You can answer.
Again, I won't try to dominate this, but there's Brownfield and Greenfield. Greenfield is net new. It's always lower cost to implement in a Greenfield environment. So it's a net new build or a net new line. You can implement IoT from the start and get it implemented for a lower cost. But if we only look at that, considering the large majority of manufacturing is legacy, we're missing the bigger window. So Brownfield presents the bigger business opportunity and the better value, but it's also more difficult to implement. When you look at that, you have to start from, keep it simple, stupid. Let's look for the biggest opportunities at the lowest cost, identify that, and then start to phase in over time what that long-term picture looks like. The ideal world, if have everything connected right from the gate and having, clear lines of understanding and data flow and everything else, it's a great vision. Practicality is not quite there yet.
Yeah. So again, I go back to when is it effective to actually put in an IoT solution if you're automated or not? Does anyone have any examples of manufacturing that seems to be the best practices or the best solution that you've seen out there from an engineering application? Don, do you have any, or
Sure.
Richard?
Well, I think a lot, as Paul mentioned, you have a lot of legacy systems. So what are you seeing from an IT perspective or IoT perspective is people adding sensors to legacy equipment. So say vibration sensors, those types of, sensors don't necessarily, have to connect into the OT space, right? So it could be something on a legacy machine where now I'm bringing in new technology, right? So I'm bringing in
So
the
like an
sensor data.
overlay, right?
Yeah,
So
yeah.
taking sensors and doing an overlay and not actually going into the control system.
That's correct. Right.
Mhm.
Exactly. Right. So that's a way you could start doing IoT per se, but you're not necessarily having to go into the OT space. But back to originally the conversation, where that transformation happens. The OT team has to start to say, do I want to do control? Do I want to do where now I'm going to open up and say, okay, I'm monitoring something. I'm monitoring sensors, or I'm monitoring trend patterns, and then I want to apply back to the business, right? So am I trying to do some predictive maintenance, or am I trying to prevent a piece of equipment from going down? Well, then how you do that, right? Do you want to send an alert on an email, or do you want to take, does the OT team want to allow some type of automated control or even manual intervention to keep a machine from having a catastrophic failure, say? So it's really, it is a combination of the OT team saying what they want to allow from an IoT perspective, but there are small steps that you can take to start integrating IoT.
Sure.
Christine, if I can just add on to that, there are applications where you need to meet safety standards. An example that we were involved with, a hydrogen site, and you need remote notification because in a hydrogen site there's no one there. It could be a refeeding depot. Okay, there's no one on site. We need to get notifications out. Now, how do we do that when there's no one on site? So it's there needs to be coming together by tonight and OT and IT to understand the regulations that have been stipulated, and okay, how do we achieve that?
Very true. So regulations, let's go back to that just for a little bit, and security. When we talk about regulations on the IT side, basically, if you think about it, when on the IT side, when we're doing cybersecurity stuff, we're worried about people getting into our finance or making sure that our emails are going out. But on the industrial side, we're not so concerned about emails, and we're worried about latency. So what are some of the things when we talk about security and latency that are really important to think about, and where do we find these types of solutions?
I think you need to understand the industry standards that are out there. So and then the requirements from IT as well, or a combination of IT and OT. And then once you have a fully understanding of what's available, what the requirements are, and then look to, okay, how do I then create the environment that will be secure? And the application, we've spoken quite a bit about, factories, but there is, as a holistic IoT possibility, but there are times when there are corporations that just want to monitor their devices out there. It could be a boiler manufacturer. They want to offer a solution, and they've got boilers installed, in the hospitals and factories, and so that that's another way. Is like, how do I meet the requirements of a hospital, a factory, a remote hydrogen site, and it's just it goes back to the drawing board. What are my objectives with to meet my customers' requirements, because they could be very they could be very different. If I had to get to a data center, if I got a UPS or a generator at a data center, you better know what you're talking about, because security is paramount. And if you don't come to the party with a secure solution, the IT department are going to shut you down very quickly.
And I think, Christine, if you're looking for some standards, IEC has a number of them that are relative to each industry. And so in the utility segment, there's going to be an IEC standard related to electric utilities. There's one for industrial. And I think it's a good place to start to read around what are the requirements from an IEC perspective, because many times that will dictate much of the work that's going on here, and at least provides a base. The other aspect you have to look at then is what's the vulnerability from a business perspective. So if you have external third parties that are accessing information, that's where the Purdue model does come into an impact that says, where do we have a protective layer where it's disconnected? I think if we look at some of the models that are emerging, one of the big questions from many of our customers is around, when does it start and when does it stop? And it's not necessarily a nice, clean answer like it used to be. And so I think that aspect around, one, third party, but rely upon IEC, look at that as the standard, or at least one of the standards around cybersecurity, and then move forward.
Yeah, I would double that. Some of the IEC standards are also not only are they going at the asset level, they're going all the way up through the from the application layer and even to the cloud, right? So some of these new, like IEC 62443-2-1, these are ones that are the industrial is starting to adopt, where the devices the sensor level are pre-certified. So that's a way to get security by design, right? And then as you add on your application layer, you're confident that the lower levels of the physical threats or of the devices have already been covered from a security standard. So these are some great new, some standards, again, that Paul mentioned. IEC is a great place to start, and you can start seeing where you're covering both your physical asset and then starting to push up into the software stack to cover even up to the application layer. And
Don, that brings up a good point, is you can rely upon manufacturers to build to a standard. That's the build it secure part.
Yep.
The keep it secure part is an ongoing effort. And I think one of the things that we've seen with our customers is they do really well to build it secure. And then all of a sudden you see this waning aspect around cyber. And so the keep it secure aspect, you can discover a vulnerability on a chip 5 years after it's been built. How do you manage to that, and how do you manage that process becomes an important part of the architecture.
And what about legacy equipment? Look, 70% of all equipment on the manufacturing floor is legacy, where on the other side, the IT side, they're doing improvements sometimes yearly.
Yep. Yeah, and I think on the legacy side, you just have to understand, one, is it connected? Two, if it is, what's the vulnerability? And if you're doing an overlay, that is a segmentation from a cyber perspective that says, I've got sensors but can't shut down the core piece of equipment. Maybe that's an approach with legacy that gives you a layer of protection until you can build into your capital expenditure the replacement or upgrade of that equipment. And I think that comes back to one of the questions around, what are we trying to fund, and how does the capital expenditures within the business support OT, or is it supporting IT, or is there a nice marriage between the two?
Yeah, I think that's one of the struggles right now, is people really coming up with outcomes that are return on assets or return on, ROI. From a perspective of, let's say, Richard, from you, where do you think the biggest ROI is, or ROA, which is return on the asset, in the market and industries right now?
I think, I believe that the last couple of years has driven a new environment, and it's that remote connectivity. how can I get to my device in a timely fashion? And it could just be, getting a text message. Okay, I have a situation on site and I need to get a result. So if you think of the storyline, how did it get resolved in the past? I had a truck roll. So now I can get remote connectivity almost instantaneously, and I can diagnose what is going on and how to resolve that as quickly as possible. And it even goes even deeper. How can I get the best person available to have a look at equipment to resolve the issues? Because you don't want someone to go along with that. I can't do this. Well, who can? And how can they get access to this equipment to get it up and running? So if you start looking at things like that, what does it cost to roll the truck? I think we've all got a good idea of what that costs. And straight away, you can look at the business case regarding savings. And it's not just savings, it's that, how can I be of service to my customers? And your customers might be someone internally. I'm creating a solution and I'm trying to help my support team within my own organization. Your support team is your customer.
Yeah, absolutely.
So I'd like to build on that. So I'm seeing a lot with customers is this idea of time in market. So the time to market on one aspect, but then there's time in market. And so building on what Richard said, I see a lot of customers thinking about services, right? So using IoT to at a later date, I can come up with different types of services, right? So, and a lot of it could be around maintenance, right? So I can provide some capabilities for you to be more efficient, tie into your ERP system and save money, keep uptime on the machine, right? So I see a lot of companies are starting to think, how can I continue to add value in the market for the product to get more ROI out of the capital equipment. And a lot of it is around services. So either maintenance or different software stacks or different functionality. You see that in a lot of industries now, right? Where the software releases with some basic functionality. And then for upgrades, you can get, more advanced functionality. So I'm seeing a lot of this thought process of, how can I deliver a piece of equipment today that does something, but then I can add services or value add types of things over the lifetime of this device to keep it more relevant longer in the market.
So both you and Richard brought up, remote monitoring and connectivity. What do you think is the reason why people need remote connectivity? Is it because the workforce is going away? You don't want to roll a truck? I mean, what are some of the reasons why people are doing remote monitoring and connectivity? And second part, what are they using when they connect? Meaning from are they using Wi-Fi? Are they using cellular? What are the methodologies and ways of doing that?
And I think that's a good carry on, Paul.
I was going to say, from our perspective, remote monitoring is there to solve two use cases. One is the efficient use of labor, but the other bigger one is avoiding downtime. So one's a hard savings in terms of labor efficiency, whether it's third party or internal. The other one is avoiding downtime. And it's really that move from automation to autonomy. Richard talked about the hydrogen plant that might not have any people there. There's numerous examples in industrial where the amount of labor is trying to be reduced or moving towards automation. Why? Because the world of having folks around with 40 years of intelligence built into their head that can just by sight or listen, hear and understand what's happening is going away. And so we're trying to replicate that within the IoT world to say, how can we automate that? So I think that's one aspect. How are people using remote monitoring? In ways they haven't thought about before. We're in the electrical space. Electrical infrastructure has always been thought of as kind of a given. And now companies are saying, gosh, I have to understand what's going on with that because it's a single point of failure. And there's a huge aspect of downtime. And you think about automotive manufacturing, it's somewhere around $5,000 to $12,000, per minute of downtime. It's some big, massive numbers. So avoiding those situations where it becomes newsworthy is probably one of those big aspects of that.
So in the beer world, it's about $100,000,
Yep.
especially right before the 4th of July, because that's their biggest time to sell beer.
Exactly.
So that brings
So
up another
that's-
thing.
that-
We
yeah,
talked
that
about
remote
remote
monitoring, yeah.
monitoring, but again, what are people doing with that besides? Is there connected worker? Are there,
Perhaps.
right?
I think it
Because-
starts with the machine. The connected worker becomes this human resource issue as well, around how much privacy and how much Big Brother aspect incorporates into that. So I think there's an aspect of monitoring an environment. So you think about lockout, tagout, who should be at what piece of equipment for what reasons. There's a health and safety reason for doing that. There potentially is a productivity reason for doing that. That might be a use case that people can get on with. But in terms of tracking each and every day, you read articles today about people putting automatic movers on their mouse so that in a remote working environment, they know they're there. That becomes potentially invasive around that. So I think that's one of the aspects there that I think is relevant. But connected worker is really about what is the context around everything you're looking at. If you see a need to protect the workers you have, or you see a need to process improvement, two different approaches to potentially the same thing. And and I'll stop after this, but you asked about Wi-Fi, cellular, Bluetooth.
Yeah.
It depends. If you've got good Wi-Fi coverage in a plant, leverage it. If you have security risks about machines operating on that Wi-Fi network where you could have a hop, then isolate it. And cellular is an easy way to do that. And you can get into LoRaWAN, which might be a combination thereof, all sorts of different opportunities there. It depends upon the use case.
Perfect. Anybody else got anything to add on that one? How you feel about connected worker or remote monitoring?
In our personal experience, we find the connected worker is becoming, I won't say industry standard, but it's hitting there. As an example, personal hazardous gas detection. People are now wearing in a hazardous environment gas detectors on their body, and these have been monitored. So I've got someone out in the field, they've now been exposed to something. I will know immediately that something has happened, and we know that this person has been exposed. What do I do about it, and what do I action? And the connectivity for these are cellular. Seems to be the common one. And as Paul said, it depends on the application as to what type of connector am I going to use. Ethernet, Wi-Fi, cellular, LoRaWAN. And that comes down to that the decision making to meet your objective. Let's have a look at all these technologies, and then you're going to throw in security, you're going to throw in ROI.
Perfect. So at my company, so I didn't tell anybody what I do. I own an industrial automation distributor, and one of the specialties that we do is wireless. And I agree with you, there's a lot of different wireless solutions out there, but there's a lot in the outdoor environment as well. So when we talk about architecture and being able to tap into things that are remote, we're seeing right now more people using cellular, right, for that remote access. But when they're in a plant situation, then it's a combination, like you said. It could be a LoRa, it could be Wi-Fi, a combination. The reason why I bring that up is, what do you guys think about as we start moving forward into the future about private LTE and IoT? Because that's something else that's coming up in the market that's outside of what we're talking about today, which is traditional cellular platforms. Private LTE is just that, private. How do you guys feel about that and working with different solutions?
I just think it's
Yeah, go ahead,
ahead,
Paul.
Jack.
I would just say, again, it goes back to the question. So, we talked earlier about, greenfields and brownfields, and from a greenfield deployment, private LTE may make a lot of sense, right? So, but if you have, again, we talked about how much is legacy. So some things you can't just move over to a private LTE network easily necessarily, right? So I think you have to look at the cost. You have to look at, we haven't talked a lot about data and processing and what you do with it. And so, everything has a cost. So if you're moving data, that's a consideration, right? And I hear a lot like, should I do 4G? Should I do 5G? And these are the considerations. The technology is emerging on 5G, but when you look at it from a communication perspective with edge devices, it's actually more expensive for the modems today, right? So if you're moving small amounts of data, does it make sense to do 5G private network? Maybe not, right? This is where Wi-Fi might make sense. So you really do need to look at how much data, what is your amount of data, how often you're gathering data, and then start to weigh off the different cost considerations, and then maintaining it too is a big cost, right? So you have to consider that too.
Yeah, and that goes back to the architecture again. When we talk about data and the amount of data that we're collecting or looking at, is cloud the best way? Pump it all up there, or is it other ways of doing that? And how do we use the cloud versus the edge when we're processing data? Anybody on that one?
It's a big factor is going to be the application. Is thinking of federal and government sites. Typically, they won't open up cloud. So I think there's a good use case for something that will be sitting on the edge. And then it goes back into your architecture. What are the requirements from the site? What is needed? What are the solutions available? Because it could be a private cell network. It could be an edge solution. It very much depends on the application.
And from my perspective, Christine, I think it really depends upon the speed of the process and the compute. But ultimately, if you want to do analytics and you want to do better and better analytics, you're going to eventually need to get that data to the cloud, because analytics is based upon that historical process with really knowledgeable people looking at it and saying, does it give you the answer you need? No, but if I add these 3 other data points, then I can. If you're trying to do that in an environment where we're dripping what we need to, and then eventually looking at how do we bring it all back, eventually, in order for us to do, I think, better analytics, when we talk about predictive, is it truly predictive? If I predict a failure a day ahead of time, but the lead time on that part or that piece of machinery is 10 weeks, is it really any value to you? So as we get better with analytics, that's going to be processed in the cloud. Why? We can embed analytics in embedded software on the machine. But how do we improve that on an ongoing basis? There's got to be a connection to that. But when you look at, does that mean I stream all my data right away up to the cloud? No. That's about what compute do you need to do at the edge? What perhaps do you need to do in a gateway? And then what do you do in the cloud? And then you can send the data on an anomaly detection that says, if I've got a failure, then send a group of data with it. And you can start there without overwhelming the system and adding cost. Cost to serve is a big aspect of that. And that's going to be related to what do you want to do with the data.
Very true. So I know we're getting really close to the end, and I want to be able to have us answer a few of the questions that are actually in the Q&A. I've been trying to ask those questions based on what people wrote, but I think some of them are really good for us just to read and reply back. Okay, so what are your guys' takes on lowering your carbon emissions footprint in the ecosystem with IoT. How do you guys see that happening?
Yeah, I was in sustainability before it was cool. Starting in 2006 and 2007 with simple carbon footprint. Sustainability is not going away, the whole aspect of looking at it. But I think there's a matter of how do you make it actually relevant to the operator on the floor. Many times we're using the same data in two different ways. We look at energy data, obviously carbon footprint is related to that. So then you have to look at the efficiency of a line. And then ultimately, what's the carbon footprint of a widget produced? There's a number of factors that can really be automated from an IoT perspective. But the question becomes, are we simply using it for reporting? It doesn't have much value. It has some value. But if we're using it to make decisions in the day-to-day case of an operator, that's, to me, is where the holy grail is helping an operator make decisions in a real-time environment day-to-day. That's where sustainability, I think, could take off.
Absolutely.
I think also we talked earlier, about this is where applying some intelligence at the edge, right? Again, back to data, right? If you really need to look at, the sample rates of things and filtering data. So do you need to send all this data to the cloud at a millisecond rate, or could you be doing it at a second or 10 seconds or even a minute, right? Then these things all cost, right? In terms of carbon footprint, this is compute and it uses power. So, being smart about data, maybe possibly processing it at the edge, as we said. So it's really architecting. So you can architect where you're being smart about, how rapidly you're acquiring data and then what you're doing with that data and how you're filtering that data, and then all the way up to the cloud if you're trying to apply analytics, making sure, as Paul said, really, maybe that's when you have an anomaly and you need to do something, right? So you're not just doing compute for no reason, right? So these are ways that you could save in carbon footprint.
Absolutely. So let's ask another question here from the audience. Let's see, which one shall we pick? Oh, has anyone on the panel heard of IPC, Connected Factory Exchange? I haven't. Is it relevant as a new standard? It's highly secure, holistic IoT plug and play throughout the industry. And it's avoiding middleware. So it's very low cost and complete and interoperable. I guess that's not really a question, but have any of you guys heard of this and any thoughts on that direction with the Connected Factory Exchange?
I would say there's probably been the battle of standards and for 20, 30 years around which standard's going to emerge, all trying to reduce the simplicity and the complexity with it. I think the question becomes, is it beneficial to the suppliers and is it beneficial to the manufacturers? And if those two things are done in combination, then it can take off. I think openness and open exchange, open protocol is a requirement nowadays. And the question is, at what level do you share? And what does open really mean? Everybody's open, but what does it mean in terms of the context of the business case you're trying to solve? So if IPC is doing some of that with that connected factory exchange, that's certainly welcome.
Perfect. So we only have 5 minutes here. So how do people get a hold of you guys? And what is the most important thing you should consider when building your architecture? Let's start with Don.
Yeah, I think we've said this a lot, but I would go back and there's your two aspects, right? So the business consideration, what are you trying to do, is very important to really have that identified. And I would say the second thing is not to put off the hard decisions. I see a lot of times people jump into the proof of concept and they haven't thought about production, so life cycle management. They haven't thought about the security architecture. So, and then of course, timeline is the other big one, right? If you need to get something done in 1 year or 6 months, you need to scope it out so it's not something that will actually take you 3 years. So I'll leave it there so the rest of the panel can talk about it.
Very good. Richard?
I would highly recommend to fully understand what is out there, what solutions are out there, because I see it fairly often where there's someone that will just grab a solution and say this is the best out there, and then a couple of months down the line they say, okay, well there's something actually better in there. I think I've seen a number of times where corporations will actually look to not actually just outsource, but look outside for assistance for that architecture. There are professionals out there, and that's all that they do. Is to look at the architecture, to have a good understanding of what solutions are out there to meet the requirements of the project.
Perfect. What about my friend Don? How would you like to close it out? Or
in terms of so closing it out, I would just say, again, from the business perspective, understand what you are trying to accomplish. So if ultimately it's monitoring, or if it's safety, or if you're trying to do predictive maintenance, you should really think about the end goal and then architect accordingly, right? And don't start with just aggregating data and sending it to the cloud and then hoping that you're going to be able to come up with predictive maintenance models or analytics without thinking about the goal first and how you're going to accomplish it, then working backwards.
yeah, not all data is created equal. Some come with consequences. So Paul, I think that, it's been really fun. We bounced around. I'm trying to answer questions as we're going. But from your perspective, how would you close this out?
I would close it out with this. Technology and architecture are going to continue to evolve. So what you're solving for today, how you employ that will probably change tomorrow. And in some cases, it's changing every 2 months. So look at, as you build an architecture, look at what are the components that are not going to have to be replaced within a short period of time, and then which components have flexibility to be replaced. So the whole idea of what's the data transport mechanism, is it cellular, is it Wi-Fi? In your architecture, look at being able to solve for both. And then you have flexibility built in for the long term, and you don't risk orphanage. So I would start with that, and then again, come back to that expected outcome. Because if you look at when do I need to do it, how often do I need to do it, and where am I going to take the outcome of that, that will determine your architecture. So answer those questions, the architecture will come along with it.
Well, perfect. I think you guys really did a great job. I know there were a lot of questions bouncing around. We talked about architecture. We talked about what is edge. We talked about security. We didn't get to one of the topics, which was digital twin, or as I call it, avatars. But I think in another session, we could definitely cover that one. So thank you very much. And I believe the next session, what is the next session? I'm not sure what the next session is, but thank you guys so much for being here today. If you have questions, feel free to reach out to any of us on LinkedIn. And thanks again. We really appreciate our sponsors, especially you three. So thank you.
Thank you.
Thank you.
Thank you very much.
Thank you. Bye-bye.